Hello, welcome all. Myself Kiran. I am from Department of SVC. Today we will learn about Introduction to Database Management System. First, let us see the outline. Definition of DBMS, importance of DBMS, types of DBMS, components of DBMS, database security, challenges, the future trends, and the last part is a conclusion. First, let us see the definition of DBMS. DBMS stands for Database Management System, and it is software that helps us to create, organize, and manage the data in a database. It makes it easy to store, retrieve, and update the information efficiently. Before going to the definition of DBMS, I would like to give one simple example. You people have come across a software called MS Excel, right? In the MS Excel, we can store the data, we can manipulate the data, we can access the data, we can retrieve the data. Likewise, DBMS is also a software like MS Excel, and with the help of DBMS, we can store the data, we can create the data, we can manipulate the data, but in a more efficient and in a most efficient way compared to MS Excel. Okay, and let us see the importance of DBMS. Centralized data management keeps all the data in one place, making it easy to manage and access. The meaning of this statement is it keeps all the data in one place, and we can easily access the data in the one place. Okay, and the data integrity and security ensures data accuracy and protects information from unauthorized access and modification. Once we store the data in the DBMS software, it protects our data from unauthorized access. That's what it says. Okay, efficient data retrieval quickly finds and retrieves specific data, improving overall system performance and user experience. Once we store the data, we can retrieve the data from the DBMS by writing a query. Okay, and data independence allows changes to the database structure without affecting how the data is accessed or used. And let us see types of DBMS. First one is hierarchical. Data arranged in tree-like structure, parent-child relationship, often used in older system. And I have given one simple diagram which shows the hierarchical DBMS. You can see college is a root node. Okay, for the college root node there are three childs, that is student, teachers, and admin. Okay, this is an example of hierarchical database. And next one is network. Data connected in more flexible structure allow multiple relationships between the records. Okay, I would like to explain it in simple words. There exist one-to-one relation and many-to-many relation. Okay, and you can see the diagram. It is self-explanatory. Okay, and it is the relational DBMS. Data organized in tables with rows and columns. Uses keys for relationships and widely adopted. Okay, here the data is organized in the form of rows and columns, and you can say it in simple words, data is organized in the form of grid. Okay, and I have given a simple diagram, you can see and compare it with the explanation. Okay, and object oriented data modeled as objects supports classes and inheritance, aligns with programming concepts, that is data is stored in the objects. Okay, and NoSQL, no limited by relational model, flexible for unstructured data, commonly used in modern applications. Okay, and let us see the components of DBMS database. Container for storage data organized into tables, each holding related information. That is, the database is nothing but it is a container, it can store the data. That's what it says. Database engine, it's a core software managing storage, retrieval, processing of data within the database. Okay, data definition language stands for DDL. Commands for defining and altering the database structures, like creating the tables or modifying the relationships. I will tell you it in simple words. DDL deals with the structure, okay, not with the data. That's what it says. Data manipulation language. Commands for interacting with data, including inserting, updating, and retrieving the information from the database. DML is nothing but we are manipulating the data, and it is mainly concerned with the data part, not with the structure part. Okay, and database schema, blueprint or design that defines the structure and organization of data in the database. And relational database overview, tables and rows, data organized in the grids, as I told in the previous slide. Okay, tables represent entities, rows are individual records. Okay, columns and data types. Columns define the attribute, and data types specify the kind of information stored in them. Attributes are nothing but the column header. Okay, and the data types are nothing but what kind of the data is the column stores. Okay, primary and foreign keys. Primary keys are uniquely identify records. Foreign keys establish relationship between the tables for integrity. primary key is nothing but your USN in the college, okay? That is unique, right? That is not taken by anyone. It is only affiliated to you. That is primary key. With the help of that primary key, they can identify it as you. That is the meaning of primary key, okay? Foreign keys are nothing but they establish a relationship between the two tables, okay? And database normalization. Explanation on normalization. Organizing data efficiently, minimizing redundancy by breaking down the information to smaller and manageable parts. Normalization is nothing but minimizing the duplicate data. Okay, that's what it says. Importance in reducing the redundancy. Avoids repeating data. Ensures each piece of information is stored in only one place. And improving data integrity enhances accuracy and consistency. Once the duplicate data is erased from the data storage, the data accuracy and consistency increases. That's what it says. And let us see the data security topic. User authentication verifies user's identity, ensures only authorized individuals have access to database. That is, database is very well secured enough to give access to concerned users, not to the unauthorized access. Access control regulates user permission controls who can view, modify, or delete the specific data. As I told, it is very secure enough to not to give any data into the bad hands or to the hackers. Okay, encryption converts the data into secure code, safeguards information from unauthorized access or interception. Encryption is nothing but we will be sending the data from source to destination, but not in the original form. Thereby, the hackers or the person who want to access the database or the storage, he can't access because it is not in the original form. Okay, and securing data transmission protects data during transfer, ensures confidentiality and integrity when information is transferred between the systems. That is, when the data travels from source to destination, database ensures that it is secure enough and so that hackers cannot hack it. Okay, and data backup and recovery. It is the most advantage of the database or MS Excel. Suppose if we delete data in MS Excel, we can't retrieve it, okay? But in the database management system, we can retrieve it. That's a main advantage. And MS Excel can't handle very huge amount of data, but Dbms can handle very huge amount of data. That's also one of the major advantage of Dbms, okay? And importance of regular backup safeguards against data loss, creates copies of restoring information in case of emergencies. That is, we can recover the deleted data from the Dbms, okay? Backup strategies. Plans for creating, storing and managing backups including frequency and storage locations. Data recovery methods. Procedures for retrieving lost or corrupted data, ensures minimal downtime and data restoration. And we can store the data and it was very fast also, okay? And ensuring business continuity, maintains operations, swiftly recovers data to prevent descriptions and ensures ongoing business functionality. And challenges in DBMS, that is scalability, ability to handle growth, ensuring the system performs well as the data and users increase, and it's very essential to manage the performance of the database management system, right? Once we store large amount of data, that's the meaning of scalability. Okay, maintenance, since the data is stored for very long time and it stores very huge amount of data, its performance may decrease, but it's very essential to maintain the database also, right, in order to increase the performance and maintain the performance. That's what the second point says. Compatibility, ensuring database management works very well with the other softwares and hardware, and seamless integration with other systems. That is, database should be compatible with other softwares, right, so that systems can interact and they can share information. And adapting to changes, flexibility, accommodation, evolving needs, adjusting to new technologies, data volumes and requirements. That is meaning of compatibility only. Fourth point is telling about the compatibility only, okay? And future trends in database management system. Cloud-based database management system. Storing and managing the data on the internet offers flexibility and accessing and scalability. I would like to give one simple example. Cloud-based database management system is, one example is Google Drive. You people have come across it, Google Drive, right? Where you can store the data and you can access it from anywhere in the world, right? The meaning, that's what the advantage of the cloud-based database management system. And big data integration, handling vast amounts of data, extracting valuable insights for informed decision making. Okay, machine learning, database optimization, using AI to enhance the database performance, accounting tasks for efficiency and improved functionality, enhancing data analysis, leveraging advanced tools to analyze data, enabling better understanding and decision making based on insights. And the last part is the conclusion. Remember the main ideas, DBMS importance. That is, it can work very fast. It can handle huge amount of data. Okay, and components, DLL, data manipulation language. Okay, security. If we consider security, it's very good. And if we consider the retrieval of data, it is also very good. We can retrieve the data. Okay, and future trends. That is, as we discussed in the previous slides, you can look into that. Encourage for further exploration, and you can explore the DBMS in the internet. You can get lot of contents. You can use ChatGPT, okay, and explore more about DBMS. It is a fascinating field with continuous advancement and application, and you can explore it. And it is one of the good concepts in the field of computer science. Okay, thank you. Have a nice day. If you have any doubts, feel free to write the comments in the comment box. I will be there to assist you. Thank you. Have a good day.